actually take the images here, do processing here. Maybe something, imagine that you want to, just by moving your hands, you want to control the Roomba, for example. So now you need something that allows you to actually detect the hands and then pass all through the computers and then move the Roomba. It seems to be simple, but it's not so simple if you don't have nice architecture like ROS that allow you to actually standardize all the messages and do nice connections here. So what we're going to do is try to do the demo and then show you how the nodes are connected and how this is working. So yeah, now let's go.
So yes, as Camilo was saying, here we have the Raspberry Pi. It's mounted in this contraption we came up with. And the camera is looking down.
So here is the camera. Raspberry Pi.
So is the camera live right now?
Yeah, it's alive.
And so the idea is, using the camera, we're going to use color trackers in order to identify where within the image the pieces of paper are. And then we've set up very simple rules in order to try to control the Roomba that's over there. And so what's going to happen is, if the papers are close together, then the Roomba's going to stay put. If the paper is separated, the Roomba's going to start moving forward. And if you push the paper forward or backwards, the Roomba's going to start rotating as well.
So something that you have to notice is that the Raspberry Pi is a small computer, right? So we actually installed already there a small version of ROS that is running and actually is streaming the images already with the messaging format that we need. So for us, it was really easy to just grab that image from there, and then with that image, we have some software that allow us to do image processing. In this case, what we're going to use is a color tracker. So on top of the image, that's what Oscar is doing here. So you can see. Maybe you can launch do we have RxGraph there? No.
To see the position?
The nodes.
Well, I'm not sure actually.
Or RQT graph or something.
Let's see if it launches. So I guess we'll check that. So in the color trackers here, here I can show you the color that I'm tracking is the green. And so if we only look at what we see as green, the white pixels there are what we see as green. And so by looking at that region, then we can draw this ellipsoid around that and find the center of that. And that point is the one that we're going to be reporting towards a Roomba. And then that's going to be deciding whether it's going to be moving forward or backwards or rotating, depending on how far away the center point is. So right now it's far enough that it's actually moving forward. And if it gets closer, then it will stop.
So something interesting here is that all this code, like the tracking code that we're using, is not something that we wrote. This actually is a famous tracker called Camshift. It starts a long time ago. It was Microsoft, like 99, something like that. And then they start doing this tracking for face tracking, and I guess it was more thinking on skin tracking. So then we're going to shift the papers with the hands, just to show you how it works. But, yeah. So I'm just going to try to go forward a bit. Then I'm going to try to rotate it a bit. And then let's see, to stop it. A little bit forward. Yes, I have to go to the other side. I'm going to try to place it in the yellow.
And so, I guess one of the cool things with ROS that allowed us to do this really quickly was that Mike already had the code that he was using for connecting the Roomba to his computer through Bluetooth. And he had his own message type set up for controlling the Roomba. And he was using his keyboard, for instance, to control it, right? So I think we can still do it right now, or? Putting me on the spot. So basically all I had to do this morning was take the color tracker that I had already working with the Raspberry Pi and just take those point positions and write 30 lines of code for Python that said, if these points are too close or too far apart, then this is the velocity that the Roomba needs to have. And then that message was already created and it already existed. And so Mike connects his computer to the wireless that this computer is connected to. And the same message that I created this morning is already working with the Roomba directly. And so it took less than half an hour to get the demo working this morning. Okay, well, I guess, yeah, that's the whole idea, though. So it's generally very
so I guess,
easy.
Yeah, the powerful thing about ROS is that you can take someone else's code, then use it for free, reuse it, and then build new things. Right? So I guess that's the good thing. And as Oscar is saying, he just took the camshift is from OpenCV, and then Mike already has implemented his code with the Roomba, and actually you can just download that directly. I think there is already a package for that.
Two of them, yeah.
So you can just download that and directly use it. And if you just learn how to communicate, it's really simple to control.